Good evening. Welcome to the last live interaction session for this course Multimodal Urban Transportation Systems. This is going to be basically a brief recap session where I will discuss some of the questions taken from different modules to give just a brief recap of the whole course. So the instructor is Professor Orkopal Goswami and I am Shankhadeep Pramanik from IIT Kharagpur. So in this course we have discussed about different components of the multimodal transportation systems, and we first discussed about what is the concept of multimodal urban transportation and what are the challenges or how to deal with these challenges. Then we moved to the public transportation. We discussed about to how to make the public transportation more attractive to the common people by taking different measures, and how to plan the public transportation effectively so that more and more people are try to use public transportation rather than their own vehicles. Then we discussed different public transportation like bus transportation or rail transportation about details and its different components, starting from the bus stop shelters to the line capacity and other components of the public transportation systems, and how to integrate it uh, how to integrate the transportation systems that we discussed. We also discussed about non-motorized transportation systems and make it attractive, which has several these NMT transportation systems has several benefits, keeping in mind the environmental aspect or the congestion scenario and other aspect. This NMT planning of this NMT infrastructure is very much essential that we discussed. And lastly we discussed about the urban transportation and sustainability topic. So with this we completed this course. Now I shall just go through some questions that covering all the weeks. So the first one is, what does this ACEFD represent in the following figure? So ACEDF, stops, terminal station, transfer station, or none of the above. So all are terminal station. Option B is the correct answer, and these are the transfer station, like where different routes are connected, and thus all other nodes are actually stops. Then what is the type of the fare depicted in the figure? Flat fare, distance fare, sectional fare, zonal fare. So it is to go this amount of distance, the fare is this one. Then again for this amount of distance the fare is somewhat increases, like that. So this one actually sectional fare, where for a particular section from 0 to x0 the fare is certain amount, then for x0 to x1 maybe the fare is another. So it is basically sectional fare. And there are also other type of fare like flat fare, where throughout the stretch the fare is same, or distance fare, where as the distance is increasing the fare is also increasing, and other is zonal, for a particular zone the fare is a particular amount. So option C is the correct answer. Then for a bus transit system, compute the average dwell time if maximum passenger flow time through all door channels is 8 seconds, has no boarding loss time, door opening closing time is 3 seconds. So average dwell time you need to calculate, and dwell time is actually the amount of time required for passenger boarding and alighting and the other operations, that is basically dwell time. So we just uh, need to add this to 8 second is the flow time and door opening and closing time is 3 second. So 11 is the answer. 11 second is the answer. Next is, what is the correct sequence for estimating bus transit capacity? Bus stop capacity low. There are different actually for what is the chronology that you have to identify. There are 4 terminology like loading area capacity, bus stop capacity, bus facility and person capacity. So what is the correct sequence for estimating bus transit capacity? So it is we first have to calculate the loading area capacity, where the boarding and alighting all the things will be done. Then in the next step we have to calculate the bus stop capacity, then bus facility capacity, then we through that we can calculate this person capacity for a particular route. So correct option will be option D. What type of sampling does this diagram depicted? 1. Simple random sampling, stratified, systematic or cluster sampling. The sample from the population, the sample is taken the odd number from each row. So it is systematic sampling. So there are different type of sampling. If it is totally random in nature, the sampling strategy is known as simple random sampling. Then systematic sampling, where a particular system is followed to sample the sample from the population. Then stratified sampling is sampling for a particular group of people, and cluster is also like sampling from a particular area or zone, that is clustered sampling. Next is 3 NMT alternatives were selected for neighborhood to encourage the use of NMT. The transport planner has to select the best alternative based on the proposed cost as estimated by the engineer's aesthetics, as judged by the urban designer and public opinion based on stakeholder survey. So determine the alternative for the neighborhood using weighted ranking method. Assume weightage 3 is assigned to the cost and 2 is public opinion. So there are 3 components. There are 3 alternatives A, B and C. The cost is different for these 3 alternatives, and the aesthetics as judged by the urban designer is given in a 0 to 100 scale, and the public opinion is also provided. Assume a weightage of 3 assigned to the cost, so cost is assumed as 3 and public opinion is 2 and aesthetics is 1. Now we need to calculate the best alternative for the neighborhood. Yes, B is the correct answer. So we need to assign some weightage. Here we have assigned the the worst one to the weightage of 1 and best one to the weightage of 3. So in terms of cost, the 70 is the lowest, so we multiplied it by 3, and it is the worst one in terms of cost, the highest cost. So it we rank we weighted given the weightage of 1 to this alternative C. And for aesthetics, the best one is this one, so we provided the weightage of 3. Similar in the public opinion, to the most unfavorable one we provide the weightage of 1, and also the weightage for a particular criteria cost is 3 and public opinion is 2. So we multiplied all these component by 2 and all these component by 3, and it is the weightage here is 1. So we multiplied these values and taken the summation of the row values. The combined score we got 14, 15 and 8. So the best one is 15, therefore B will be the B alternative. B is the best option for this neighborhood. Next is, what does this red line represent in the graph above? Demand, supply, surplus, subsidy. So this one, the red one is supply and the green one is demand curve. So option B is the correct answer. Now consider this hypothetical data where K is the density and U is the speed. So speed and density is given of pedestrians along a footpath. Determine the parameters of the flow model using green shields relationship. Use the method of least square. So this one may be time taking, so you have to I'm just discussing this one. So K value is given and U value is given, and for least formula for least square, that we need to, the green shield relationship is U equal to A plus BK. Now we need to find out this A and B. To find out A and B by the least square, we have the equation, this one is for B and this one is for A. Now we, according to that, we need to calculate these values of xi, x bar, etc. So this one is x and this one is y. Now if I average these values, then the average of these values is x bar and average of these u values is y bar. Now we need to calculate each of the term xi minus x bar, yi minus y bar. That is, xi is the, for a particular, suppose in this case xi is 171 and x bar is 102.5. so similar to that we need to calculate these values and yi minus y bar, then we need to multiply it and get the values, and in the denominator it is xi minus x bar square. So these values we also need to calculate, and from after calculating these values and putting it in this equation b, the b comes as minus 0.2, and by taking the value of b as minus 0.2 we can calculate the value of a, and finally if we got the value of a and b, then we just use this green shield model relation and put the value of a and b. Here a is 40.8 and b is minus 0.2, so option a is the correct answer. So we need to remember this formula and just calculate different terms in this formula, and we can get the value of a and b. So next is, consider the following graph and what will be its R square value. 0.51, none of the above. So these points are the actual data, and this line is represent the model relationship, and the model that is given as this one. So this line fit every data here. So as the line fit every point is crossed by this line, so the R square value is 1, and if that is there is a there is a very high relation with the actual data and model relationship, and this kind of fit will be where R square is 0. So this model actually didn't fit this data well, so here R square is 0 and this one is R square 1, and R square value generally ranges from 0 to 1. Next is, a 3-meter wide footpath in an institutional area is barricaded with guardrail on both sides. The existing peak flow rate is 1200 pedestrians per 15 minutes. What will be the PLOS? Use Indo-HCM PLOS and shy away distance definition. So it is an institutional area and barricaded with guardrail. You have to use these two charts and calculate the PLOS. Then take the value of 0.5 here. Is it D or C, I guess? Have you taken the value of this one as 0.5? It may be changed depending on the value, or the calculation may be, I have to check, but here the shy away distance, if we consider 0.5, then there is a 3-meter wide footpath in an institutional area is barricaded with guardrail on both sides. So if we take the shy away distance of 0.5 in both sides, then it will be 2 meter. Now pedestrian flow is 1200 pedestrians per 15 minute, so it will be 80 per minute, and this table is given in pedestrian per minute per meter. So 80 per minute, and we need to convert this pedestrian per minute to per meter. So the effective width of the footpath is 2 meter, so we can just divide it by 2. So 40 pedestrian per minute per meter will be the pedestrian flow rate. Now it is given a institutional area, so for institutional area 40 pedestrian is 36 to 42 value is LOS of E. So option C is the correct answer. Next is, how do we calculate peak hour volume from ADT, where K is the peak hour factor and D is the directional split. So peak hour volume can be calculated from ADT as ADT into K into D. So ADT is the average annual daily traffic, K is the peak hour factor, and D is the directional split. So option A is the correct answer. Next, which index is used to evaluate capability of roadways to accommodate both motorist and cyclist? Entropy index, PSI, BCI, and none of these. BCI stands for Bicycle Compatibility Index, and it is basically used to evaluate capability of roadways to accommodate both motorist and cyclist, and it is very useful to determine for the whether that area or city can handle the cyclist and motorcyclist together, especially in older cities. So option C is the correct answer here. Next is, calculate time gap for a platoon of 40 school children, 5 in a row, where consecutive time is 2 seconds, width of crossing section is 8 meter, and walking speed of the children is 1.1 meter per second. Assume a startup time as 3 seconds. This formula can be used. Yes, it is B. So the formula is this one, and we need to calculate the minimum time gap. Width of the crossing is given uh, width of the crossing is given 8 meter. Then pedestrian speed is also given 1.1. Then this TC value, consecutive time between two pedestrian, is also given, and n we can calculate that 40 school children, 5 in a row, so there will be 8 rows. And lastly, the consecutive time between two pedestrian is given as 3 seconds. So we can use this formula, and the answer will be coming out as 24.3. A bicycle is to make a safe turn without skidding at a corner with a turn radius of 18 meters. Determine the maximum speed at which the bicycle can turn without skidding. Assume the friction value as 0.25 and theta as 0.15. G is 9.81. This is the formula. Yes, B is the correct answer. So this is the formula, and R is given 18 meter turn radius, G is 9.81, tan 15 degree, and the friction value is 0.25. So 1.777 is the correct answer. Next is, a tall building is located 40 meter from the straight line of a sight of a car at point C. So the car is at point C, and the tall building is located 40 meter from the line of sight of the car, and 50 meter from the straight line of sight of a bicyclist at point A. So in here the bicyclist, and here there is a car. Now determine a side distance available to the bicycle if the car is at point C is approaching the unsignalized intersection, which is 100 meter away at a given instant of time. So this value is 100. Now you need to calculate the side distance available to the bicycle when the car is at C and bicycle is at A. So the bicycle is at A and the car is at C, and it is saying that a tall building is located 40 meter from the line of sight of car, from the straight line of a sight of a car, and 50 meter from the straight line of sight of a bicycle. So if we consider these two triangle A, B and C, and A, D and E, then BC by AB, so this one divided by this one, this one, and for this AD triangle ED divided by AD, so this much portion. Now what we need to calculate is this DA, that will be the side distance, and the distance from B to C is given as 100 meter. This one, the point C is 100 meter away from the intersection point. So this is, if we say dB, then 100, and A, that is the distance of the line of sight of the cyclist to the building, is 50 meter, and from the car to the building it is 40 meter. Now this total distance, and this one is 40. So dA and another is dA minus 40. So by calculating we can get 80 meter. This total distance is 80 meter. And this, so from similar triangle we can calculate the values. Next is classify the following push and pull measures and choose the correct answer. Road pricing, street design, for space allocation, BRT, LRT, integrating transit system, and traffic calming. You have to put it in the right column, push or pull measure. These both are travel demand management strategies to encourage to manage the demand of particular road space. So push measures are like road pricing or congestion pricing, speed limits. This will discourage the people from using the private mode of transportation. So if the pricing, if they have to give some congestion pricing or road pricing, then they will obviously be discouraged to use their private mode. So these measures are push measures, and pull measures are basically those measures that will attract more and more to the public transportation, like giving priority to the bus service through bus rapid transit system or LRT system, then particular park and ride facility or bicycle lanes, or providing the pedestrian zones. These things will promote the public transportation and non-motorized transportation also can be more promoted through these pull measures. So here road pricing and traffic calming is the push measure, and street design, BRT, LRT or integrating transit system is pull measure towards the public transportation. So option D is the correct answer. Next is a speed density relationship Vp equal to 60 minus 10 kp. Using the above, develop the equation showing the relationship between Qp and Vp. So you need to find the relation between flow rate and pedestrian speed. The basic relation is Q equal to Kb, and you can use that relation to derive the equation between Qp and Vp. So Q equal to Kb is the base equation. Now here we need to get the relation between Qp and Vp, and the equation given is between Vp and Kp. Now if we convert from this equation, Vp equal to Qp by Kp. Now if we just put these values in the given equation, Vp equal to 60 minus 10 kp. So if we put this one here, then Qp by Kp equal to 60 minus 10 kp. So Qp equal to, if we just multiply this kp in here, so 60 kp minus 10 kp square. Subsequently, for Qp Vp we can use the kp, this is between Qp and Kp relation, and for Qp and Vp we can use this Kp equal to Q by V, that is also got from here, and we need to put it in this equation. So QP equal to 60 VP minus VP square by 10 will be the ultimate answer. Option A will be the correct answer here. Next is total service time divided by total travel time with respect to public transportation is referred as running index, passenger waiting index, interconnectivity ratio, travel time ratio. So we discussed about different ratios like travel time ratio, level of service, interconnectivity ratio. Here it is saying total service time divided by total travel time. So total service time divided by total travel time is the running index, and travel time ratio is the travel time by public transportation divided by travel time by car. So that is travel time ratio. So here the option A will be the correct answer. Next is transit dash is measured by the percentage change in transit demand per percentage change in fare level. So what is measured by percentage change in transit demand per percent change in fare level? It will be fare elasticity. Elasticity is basically change in something divided by something. So in this case it is for fare level. So percentage change in transit demand per percentage change of fare level. So it is with respect to fare. So it is fare elasticity. Next is a footpath of 2 meter in a residential areas is to be redesigned and improved by giving importance to the perception of pedestrian in terms of satisfaction and their importance on various qualitative footpath attribute. So different attributes are given and response are collected from 200 respondents. Now we need to calculate the walkability index and corresponding quality of service of the existing footpath as per in the HCM with using this table. So it is basically just a summation that mean importance is given and the mean satisfaction also given, and walkability index is the multiplication of these two, mean importance and mean satisfaction. So we need to multiply each row for 10 alternatives for these 10 alternatives, and if we add all the values then we can get the walkability index, and it is coming as 94.43. Now it is in this quality of service table it is less than 106, so it will be of quality of service C. So option B is the correct answer. Next is queuing takes place when mm, arrival rate is less than, greater than, or equal to service rate. Option D is the correct answer. So the service rate is when the service rate is low and the more and more vehicles are coming, then that time the queuing vehicle or maybe person are coming, that time queuing takes place. Last one is determine the travel time ratio, level of service and interconnectivity ratio for a metro system between two origin destination pairs whose riders had the following average value of travel times. The commuter undergoes multiple access and egress trips to use the metro system. So travel time attribute and the values are given, and you need to calculate TTR, level of service and interconnectivity ratio. C is the answer. So we need to first calculate the total time taken by public transportation. So travel time ratio is the travel time by public transportation divided by travel time by car. So if we calculate the public transportation, it is basically access time, egress time and IVTT, that is in vehicle travel time. Access time, egress time and IVTT are given, so it is 54 minutes. And out of vehicle travel time is basically access or egress time, that is that will be required to calculate the level of service, that is OBTT divided by in vehicle travel time. And interconnectivity ratio is the access and egress time, which is 26 minutes, and total travel time is 54 minutes. So if we calculate this value, 1.8, 0.92 and 0.43 will come, and option C will be the correct answer. So with this we concluded this course, multimodal urban transportation systems. I wish best of luck for the exam, and it was a great experience.
Sir, I have done 6 assignments
Okay.
instead of 8, and it is written there that we have to, they will take top, I mean, the score of top 8 assignments.
Okay.
So, am I eligible for the certificate if I give the exam Am I eligible for the certificate?
I think you are eligible. Just
Because I didn't do two assignments.
I think it will not be problem because the marks will vary according to that. But I don't think it will be a problem. But still, you can write to the NPTEL team or the mail ID, or you can write to Orkopal sir also. He can sort out maybe. Mm.
Okay. Okay. Sir, mainly the question will be MSQ and MCQ type.
Yes, like this type of questions, and the similar to the assignments. And when is the exam?
26.
26. Okay. It is in the IIT Kharagpur.
It is not in IIT Kharagpur. It is 53 kilometer away.
Oh, where?
Let me tell you, some institute of just a minute, some institute of science, something in Medinipur.
Okay. Oh, I thought it held in IIT Kharagpur itself.
Yeah, I also thought that, but I don't know how it happened.
Oh. You are giving the exam, right?
Yes, sir.
Okay. Best of luck.
But it will be common from assignments.
I guess so. Like similar to these questions. Actually, professor generally makes the question, and I guess it is similar to these assignment questions. Not very different.
It is in mm, it's opening. Just a minute.
Yeah.
It's in Paschim Medinipur Institute of Science and Technology.
Oh, I don't know where.
Dhurabila, Dhamkuria, something, Paschim Medinipur.
Oh, didn't heard about this place.
Yeah. Previously, it used to happen here, na?
I'm not sure actually, but there is a like office and all. Therefore, I thought it should have been here.
Yes. Okay.
Anyway,
Okay. Thank you,
oh,
sir.
okay. Hello, I have just discussed the question. If you want, we can just repeat. We have discussed about different questions, and uh, if you have any specific query, you can also ask. Just a minute. So we the first question was this one: what does this ACEFD represent? Like these questions are similar to the assignment one. So you can try to answer the question, or if you have any particular doubt, that you can also ask. No, no, it's okay. You can just answer the question, or if you have any specific query. So here okay, uh, it is terminal station, right? Then what is this type of fare depicted? Right, this one is sectional fare, option C. Next is you have to calculate the average dwell time if the maximum passenger flow time is 8 seconds and no boarding time lost, and door opening closing time is 3 seconds. So it is just the some average dwell time means summation of the passenger boarding alighting time and other lost time or door opening closing time. So we just have to add these values, all door channels, the passenger flow time is 8 second is given, and the door opening closing time is given as 3 second, and there is no boarding time lost, so it will be 11 second. Option A. Next is, what is the correct sequence for estimating bus transit capacity? So there are four components. So the correct sequence, actually, first we need to calculate the loading area capacity, then bus stop capacity, then bus facility capacity, and ultimately the person capacity. So option D will be the correct answer here. Next is, what type of sampling does this diagram represent? No, there is a like it is uh, sampling from a population, the odd one, 1, 3, 5, 7. So it follows a particular system. So it is systematic uh, sampling. And cluster sampling is where we collect a particular road, like for collector road the sampling is done, and there are other sampling also. If the sampling is totally random in nature, then that will be simple random sampling. And stratified sampling is a, for a particular group of people, like uh, male, only from male or female, this kind of sampling are stratified sampling. And this systematic sampling is as shown in this diagram also, that the odd house numbers are being surveyed maybe, so it is systematic sampling. Next is, three NMT alternatives were selected for a neighborhood to encourage the use of NMT. The transport planner has to select the best alternative based on proposed cost, aesthetics is also given, and public opinion. Now determine the best alternative for neighborhood using weightage ranking method. Assume weightage 3 is assigned to cost and 2 is to public opinion. And nothing is set for aesthetics, so it will be considered as weightage is considered to be 1. So here the cost, aesthetic and public opinion are given. Correct. B is the correct answer. So we need to give a particular weightage to maybe the worst one is given here as 3 and sorry 1, and the best one is given as 3 value, and middle one is 2. Now on the for cost the weightage is 3 and for public opinion it is 2. So if we just total all these rows sum and compare between these three alternative, the option B is the highest, so option B will be the correct answer here. Next is, what does this red line represent in this graph? Correct, it is supply, and the green line is demand. Next is, consider the hypothetical data where k values are given, u values are also given, and determine the parameters of the flow model using Green-Shield's relationship. Use the method of least squares. So it will be quite time consuming, so I am just reading this calculation, that x values are given and y values are given, so k for k and u. Now the we need to calculate this a and b in Green-Shield model. So the formula for b is we know, and from the b we can also calculate the value of a. Now we need to calculate, we need to first find out the average of this x and y, and then this xi will be the for a particular observation, and x bar we already know, so we need to calculate this xi minus x bar and multiply it with yi minus y bar, so we can get the values, and denominator is xi minus x bar square, so we can also get these values, and from this equation we can get the value of b, and from that if we put the value of b in this equation for a, we can also calculate a. Now the relationship will be u plus 40.8 minus 0.2 k. So option A will be the correct answer. Next is, consider the following graph. What will be the r square value? Correct, it will be 1 because data fit the model relationship. Next, a 3-meter wide footpath in an institutional area barricaded with guardrail on both sides. The existing peak flow rate is 1200 pedestrians per minute. What will be the PLOS? And you can this is said as guardrail, so the shy distance will be 0.4 to 0.6. You can take the middle value of 0.5. Right, C will be the correct answer here. So we first need to calculate the effective width, which will come as 2 meter. Then pedestrian flow we need to calculate, it will 1200 per 15 minutes, so 80 per minute. And from this table we can get for the institutional area, it will be LOSE. So option C. Next, how do we calculate peak hour value volume from ADT, K and D? Right, ADT into K into D. Next is, which index is used to evaluate the capability of roadways to accommodate both motorist and cyclist? Correct, it is basically bicycle composite index. So the option C will be the correct answer. Next, calculate the time gap for a platoon of 40 school children, 5 in a row, where consecutive time is 2 seconds, width of crossing section is 8 meter, and walking speed of children is 1.1 meter per second. Assume startup time as 3 seconds. Correct, it will be option B. So you can use this formula, W by S plus TC into N minus 1 plus TS, and it will be 24.3 second. Next is, a bicycle is to make a sharp turn at a corner with a turn radius of 18 meter. Determine the maximum speed at which the bicycle can turn without skidding. The friction value is given as 0.25 and theta is 15 degree, and G is 9.81 meter per second square. So this one will also be option B. The formula is root over rg tan theta minus fs. So r is the radius given as 18 meter, g is 9.81, 15-degree angle, and fs is the fs is 0.25. So it will come as 1.8 meter per second, option B. Next is a tall building is located 40 meter from the sight line of a car and 50 meter from sight line of straight line of sight of a bicyclist at point A. Determine the sight distance available to the bicycle if the car is at point C and is approaching at the unsignalized intersection, which is 100 meter away at a given instant of time. So the value of this A is 50 meter and B is 40 meter. So the value here between B and C is given 100 meter, and you need to find out the side distance available to the bicycle if the car is at C and is approaching to the unsignalized intersection. So this DA distance we need to find out, and the value of A is 50 meter is given, and the tall building is located 40 meter from the sight line of the car, so this B is 40 meter. Now if we consider these two triangle A, B and C and A, D and E, we can say that BC by AB. So this line and this line is corresponding to ED of this line for this triangle, this ED line and AD line. Now this total distance is DA and this one is 100 meter. So if we put the values here 100 and DA and A value is 50, so we can get the value of DA, which is from bicyclist to the line of bicyclist point to the crossing point. So it will come as 80 meter. So option B will be the correct answer here. Next is classify the following push and pull measures: um, road pricing, street design for space allocation, BRT, LRT, integrating transit system and traffic calming. These are the 5 strategies of travel demand management, and you need to classify this according to push or pull measure. Push means where people are more people are discouraged to use the private mode of transportation, and pull is more promoting more sustainable mode of transportation or public transportation and non-motorized transportation. So you need to classify these travel demand management strategies into these push and pull measures. It will be option D, because uh, BRT and LRT are the pool measures, where BRT or LRT means like mm, uh, giving more priority to the bus, so that a dedicated lane for bus. So this BRT and LRT will come in pool measure. So option D is the correct answer. Next is speed density relationship is given as Vp equal to 60 minus 10 kp. Now we need to find out the relationship between Qp and Vp. So you can use the formula Q equal to Kv, and from there you can derive the equation for Qp and Vp. it will be option A. So is Q equal to KB, from there KP equal to QP by VP. Now if we just put this value in this equation 1, we can get QP equal to 60 VP minus VP square by 10. Next is total service time by total travel time with respect to public transportation is referred as running index, passenger waiting index, interconnectivity ratio, travel time ratio. Correct, it will be running index. Option A is the correct answer. This one. Next is transit dash is measured by percentage change in transit demand per percentage change in fare level. It will be basically fare elasticity. It is saying about fare that the percentage change in transit demand per percentage change in fare level. So and elasticity is basically percentage change in transit demand with respect to change in some other parameters. That is basically elasticity. So here the context is changing of fare, so it is fare elasticity. Next is a footpath of width 2 meter in a residential area is to be redesigned and improved by giving importance to perception of pedestrian in terms of satisfaction and their importance on various qualitative footpath attributes. So there are 10 attributes are given and 200 responses were collected. Now you need to find the walkability index and corresponding quality of service from this given table. Yes, walkability index is the sum of these A and B values. So if we just multiply and sum, it will be 94, around 94, which will come as quality of service C. Next is queuing takes place when what is the condition between arrival rate and service rate. There may be some questions, maybe like some calculation based question may be there, but it will be according to the time. The question paper will be set such that it will not take maybe many times. Here like here that there are 10 attributes, maybe 2 or 3 attributes will be there. right, it is arrival rate greater than service rate. And the last one, determine the travel time ratio, level of service and interconnectivity ratio. Given these travel time attributes are given, and the commuters undergoes multiple access and egress trips to use the metro system. So you need to calculate TTR, LOS and IR. Correct. C is the correct answer here. Travel time ratio, level of service and interconnectivity ratio will be 1.8, 0.92 and 0.48. So these are the questions for this recap class, and that's all. If you have any queries, otherwise best of luck for your exam, and it was a great experience for this course. So if you have any queries you can ask.
Okay, thank you so much, sir, for the time, for being impactful, and for being very understanding doing this coursework.
Thank
Okay, I just have a few questions regarding the exam.
you.
So
Okay,
I see that question number 19 was fill in the blank. Do we have fill in the blanks?
sorry.
Uh, do we have fill in the blank? The questions like question number 19.
Okay, these type of question may not be there because mainly multiple choice questions will be there maybe, or maybe you have to put some values MSQ or something like that, but not maybe something like typing or like
So
that.
will we have essays questions, or we'll have to explain or do some calculation and show work?
I think
Or like
uh, mainly multiple type questions like this assignment, these type of questions will be there. I am totally not sure, but I think it is the case. Like this, similar to the assignment question. Generally, a professor set the questions. So, but generally it will be MCQ or MSQ. But you can just for the confirmation, you can just post it in the discussion forum. Maybe the official TA will reply this one. They may know better actually. That's why.
Okay, so based on past questions, do you know the total number of questions since the test is for 3 hours?
Mm,
Do you know
mm,
if it's 50 questions or
no, I don't think you can just write this query, but I don't think they will communicate, or I am not sure actually what these queries can be actually. The official TA of this course will can be can be say this answer to these queries, so you can post this in the discussion forum. They will they may know it better.
okay, so thank you.
Okay, thank you for joining.
Okay, so.
No.